Good evening, friends. Welcome back to another session on logistics analytics. In previous session, we discussed about EDA and data preprocessing. Right? So in today's session, we will be discussing on unsupervised machine learning technique. And in unsupervised machine learning technique, we will be discussing on K-means. All right. K-means clustering is one of the simplest and famous unsupervised learning when it comes to machine learning. Okay. So when you say clustering, what do you mean by that? It simply means that you're collecting the data and you're aggregating the data together and you're finding the similarities between the data points, right? When you have these data points, right, you look for similarities, and based on the similarities, you form the clusters. Okay, what do we do is we have these data points, okay, and then you find the centroids, okay, and here in K means the value of K is predetermined. Okay. So first what you do is you fix on the K value, right? The number of clusters that you want. Okay. And you assign each data point, or what you call as centroid, from the input data point, that is input data set, right? And then you calculate the variance. So let's say you have the data here, data point here. These are few data points, and then you calculate the variance. Okay, and you place the new centroid. Let's say this is the center. So you move from center to another. Okay, and you keep repeating these steps until you find a new centroid. Okay, Now, how do you choose the value of K, that is number of clusters, right? How do you choose the K value? So here you choose the optimal number of clusters. You go with the optimal number of clusters. One of the method is the elbow method. Okay. This is one of the popular methods. Okay, we look at within clusters, sum of squares. Okay, so this is one of the popular method. You're looking at within cluster sum of squares. Right. So what it does is it is looking at the data set and the values. Here you have different K values. Okay. And those K values can range from 1 to 10. Okay, we'll also do hands-on with our data set. Okay, and then you plot the curve between the calculated within cluster sum of square, right? Now this also you do a data pre-processing, and data pre-processing we already looked at it. What you do is you import the library and you do a EDA on that. Okay, ELPO method helps you find the optimal number of clusters, right? We also train the data. Here we train the data. That is, we train the model, and then instead of going with 1, 2, 3, 4, we look at 3 or 5. Right? And you should also be focusing, that is, you need to be mindful when you're choosing the right number of clusters. Okay, let me put that. Now, how do you find out the centroid? What do we find in the centroid? So here are your data points. You calculate the distance. If this is your data center, and then you calculate the distance between these two data points, and then you move to the next centroid, and then you calculate the distance between these two data points. Like that, you do with all the data points you have with your centroids. Okay. So the process starts here by, it will first group the selected centroids, and then it keeps repeating. Okay, it is a iterative task. Okay. So what are we doing here in k-means? First, we select the number of clusters that needs to be generated, right? And you categorize the data set or the data based on the number of, like, you have the data points, right? You categorized, and you also look for similarities between the clusters. Okay. And we do a within cluster sum of square, and the sum of squares distance as well between the data points. And this is between the data points and centroids, not just between the data points, between the data points and the centroids. Okay. So now, if you look at implementing k-means clustering, you're grouping, right? Segmenting. It will work on, we are basically we are clustering the airports, right, in our data set. And when we do a hands-on, we will look at the code as well. Okay, how we are able to look at the elbow curve. Okay. And in this particular logistic analytics, in this domain, we will be able to cluster cluster the airports. Here we are clustering the airports. Okay. And if you look at pros and cons, the centroids can be changed. Okay. The centroids that we look at can be changed. And the data that is generated, okay, when you have the data in this sequence, it will have an impact on the output as well. Okay, and it is also having impact on the k-mean, that is choosing the k value. Okay. So let me pull this up as well. I would like to show you a data set, and we will be doing a hands-on on the code. In hierarchical, that is in unsupervised learning, we also have hierarchical cluster, right? And when you compare this with k-means, right, these are way more complicated. It generates a complicated clusters. Okay. And that will also have large number of variables as well. Okay, at this point we are looking at, we are comparing hierarchical clustering with k-means in a way. Okay, and these groups can also be sub-segmented. Can you think of any other department that we can implement k-means, now that you know what exactly k-means does and how to calculate the k value? At first place, we are segmenting the airports, right? We know the centroids. And we also motor value, K value. Here we can, once we have our data points and form the cluster, that is cluster 1, cluster 2, cluster 3. We can select these clusters and kind of initiate the loop for a iterative task. Okay, let me launch my spider at this point. Okay. So here I am importing the library, right? Import is a function. Pandas. Pandas is for data manipulation. We know this, we discussed about this in our previous session, right? And then I'm also importing NumPy and matplotlib.pylab. This is for data visualization. Okay. I'm also importing, that is, I'm writing from sklearn.cluster import kmeans. Okay, this is one of the packages that is available. Okay. Now, in this particular data set, I'm saying I am defining a variable called dhl1 is equal to pd dot read underscore xl. Okay. Why pd? Because we are saying import pandas as pd. We're giving a short form. And then now I'm passing the path of the data set where I have saved in the local system. Okay. Now let me pass the location. So here I have it. Okay, this will be considered as a string. Okay, I want to replace this to forward slash, or I can simply go ahead with backward, double backward slash. It works both ways. You run this. Even before you run this, you need to import the libraries. Right? It need not be Spider, friends. You can also try out on Jupyter Notebook or Google Colab. Okay. Now when I run this, now here I have my data frame. Okay. So here I have these columns. Right? I have 5 columns and 983 rows. Are you able to look at this? See, I have OD airport, origin airport, destination. Yes. So this is your data set, data frame, basically. Right? If you keep scrolling down, you will have 983 rows. Right? And then I say DHL1 dot describe. Okay. I would also want to look at the data types that I have in my data set. See, these are my columns. OD airport pair, IDX origin airport. Okay, this is my destination airport, origin airport, and estimated yearly available freight tons. These are few columns, all the columns that I have in my data set. Now, I would like to drop the OD airport pair column, right? Because that is not required. Okay, let me run this. Right. Okay. And we are doing a normalization function next. Right. And in min and max scaling, the range of the data points are 0 to 1. Okay, they are between 0 to 1. Okay, let me run this. I'll have to select the entire code and run. Multiple lines of code, right? Let me call this. So here, the normalized data frame, here we are considering only the numerical value in our data set. Okay. And then next we are looking at the script loss. Okay, we are going with script loss just to determine the number of factors that it is retaining in the exploratory factor. Okay, let me run this. This is total within sum of squares, TWSS. This is the variable that I am defining. And I'm starting a loop. I'm saying for I in K, K means is equal to, K means of N clusters is equal to I. If you look at this, we have a range from 2 to 9. These are the index. Okay, this is the range that you are looking at. And then the loop. Total within sum of squares is what we are getting. Right? Now, let us look at script plot. Right? So we are determining the factors. I run this. See, here is my elbow curve. Next, I am selecting 5 clusters from the above script plot. Okay, I want to have the optimum number of clusters. You can also look at the plots here. Then I'm selecting the optimal number of clusters, that is 5. I'm considering 5. I'm writing model is equal to k-means of n underscore clusters. And I'm passing 5 as my clusters, number of clusters. Okay. See, here you're looking at the number of clusters and total within sum of squares. Okay, that is where you're getting this. See, the elbow curve. And right after that, I am selecting the number of clusters. Okay, is that clear? And I say model dot fit of data frame, that is df underscore no. Okay, so here we are assigning the cluster to each other, that is each row. Okay, we say model dot label. See, are you able to see this? So you're getting the labels of clusters assigned to each row. And this is how your output looks. Okay, and then now I would like to convert the NumPy array into pandas series object. So you say model, that is MB, is equal to PD dot series of model dot labels underscore. Okay, here we have assigned the labels, right? Right? And then here we are converting the NumPy array into pandas. Let me run this code. Now, if you look at this, This is how it looks like. The clusters that are assigned to each row. If you keep scrolling this, you go to 0, 3, 2, and then now you are creating a new column and assigning it to a new column. You're creating a new column now. DHL of review is equal to M. Now, initially, how many columns did we have? Right? A new column is created. Now let us look at, should be review. This column is created. So head, that is DHL dot head, keyword head will show you the first 5 rows of your data set, data frame. Okay, index location. This is showing the index location. DHL is equal to DHL dot index location. And then you're passing 301, 2. And now if you do a pass head function, so it is giving great circle distance between airports, and this is in kilometers, estimated yearly AFT, that is available freight tons, is what we get. Okay, the initial 5 rows, we are able to look at this. Okay, I will import OS, okay, to access the files. Right? Then I will write os.getCWD. This is basically current working directory. Okay, and then if I run this, so here it is giving me the location. All right. So we have normalized the data. We looked at the data set, right? And if we want to drop the columns, we can. Okay, and you can drop the columns which are not required, and you are not deleting the columns, you are only dropping the column. Okay, you might not want to delete the columns from your data set. And this again, the clusters, the number of clusters you select might vary with when you start researching on your model, right? When you build your model, the optimal number of clusters that you would want might change, okay, depending upon various factors. Okay, we can also look at scree plots. So what it is giving us? At the beginning of our discussion, I did mention about the elbow curve, right? So we are also looking at the independent variables. But we extract the independent variables. Always when you predict the range, it will be from 0 to 1. This one. The minimum and maximum range is what we were talking about. Okay. And of course, you have to do a data pre-processing EDA and all of this. Have to do that, and then you start building the model. Okay, you need to cleanse, you have to do a data cleansing, all of that. Only after that you start doing building the model. Yes, if it is a simulated data, that is a different scenario altogether. Okay. Right, friends. That's about k-means clustering. It is unsupervised machine learning technique. And k value is predetermined, and you need to all right, friends, we will stop our discussion here for the day, and we will continue in our next session.